What's up, guys? Today we're going to be talking about minimums and maximums of graphs, and specifically we're going to be looking at polynomials. So a minimum and a maximum is a place where you have a highest point or a lowest point on a graph. And we talk about them in terms of relative minimums and maximums, and then we have absolute minimums and maximums. So relative minimums, relative maximums, just means it's the highest or lowest point in that area. So look at this graph. This is a relative maximum. I'm going to abbreviate it, relative maximum. This is a relative maximum because it's the highest point in its region. If you were riding this like a roller coaster, you'd be going up, you hit the top, and then you'd start to come back down. So that's a relative maximum. It's not an absolute maximum because you can see the graph does continue to go above that point later on. So it can only be an absolute maximum if it is the highest point in the entire graph. Okay, and similarly, this is a relative minimum because it's the lowest point in that region. There's nothing else around it. It goes down, hits the lowest point, and starts to come back up. But it's not the lowest point in the entire graph because it does continue down. So again, maybe put arrows here. We're assuming the graph continues and that those are basically the ends. It's just going to continue up and continue down from there. Now, it's worth noting that this is, if you remember from the previous unit, previous lesson, this is an odd function. We know it's an odd degree function. It looks like it's cubic. It could be something else, but it looks like it's at least cubic. It has to be at least cubic because there's two turning points. So what you should notice is because these go up to the right and down to the left, or vice versa, there's never going to be an absolute maximum. There's never going to be an absolute minimum on an odd degree function. It can only have relative minimums or maximums because it does go up forever and down forever one way or the other. Now here's an example of an even function, and this has to be at least degree 4 because we have 1, 2, 3 turning points. Has to be at least degree 4. Could be higher, but it has to be at least degree 4. Okay, so again, this one's going to go up forever to the left and right, but that means we may actually have, and we will actually have, somewhere an absolute minimum because this graph does not go down forever. So somewhere it has to have a lowest point, and that's right here. This point would be an absolute minimum. It is the lowest point in the entire graph, assuming we've zoomed out far enough on our graph that we see all the important information. Now, we're going to assume that this goes up forever to the right and goes up forever to the left. It is entirely possible sometimes that the graph may turn back around somewhere. So if you're doing this on a graphing calculator, you need to make sure you're zoomed out far enough that you see all the relevant information. If I know going into it that this is a 4th degree function, for example, and I see the 3 turning points, I know that's all there is because there can't be a turning point out here. I see all 3 turning points there. That's why it's important to know how many turning points there is when you're graphing. If you can look for them and find all of them, then you know you see all the relevant parts of the graph. So again, what would this be? This would be a relative maximum because it's the highest point in its region, but it is not the highest point in the graph. And in fact, this graph will not have an absolute maximum because it's going to go up forever. And then this will be a relative minimum. All right, so we're going to look at a graphing calculator, and we're going to see how to actually calculate these minimums and maximums. And I'm going to show you the buttons to press. So if you ever forget the buttons, you can come back and watch this video, pause it, rewind it, do what you need to do. All right. So let's take a graph. First of all, let's remember how to enter a graph. So we go to the y equals, and each one of these y's is going to be a different equation that we can graph. And so let's graph a polynomial that we want to find the minimums and maximums for. So we're going to go negative 2x to the 4th power. And yours may look a little different. You may not have the actual raised exponent here. You may just get the little caret symbol at the 4. That's okay. There's the right arrow to get out of the exponent. Let's see, minus 2x to the 3rd. And make sure you actually use the minus when you're subtracting, and you use the negative sign when you need a negative, because on the calculator they are different buttons. Be careful about that. I see that a lot. People put a minus sign, or put a negative sign here, in which case you'd be multiplying these two terms instead of actually subtracting them. And this would just be negative. So we don't want to do that. And let's say plus 2x squared. So x. And squared, you can just hit this button. It's nice. Plus 7. Okay, and I have no idea what this graph's going to look like. It's just one I pulled off from somewhere. So we'll see. So if you want to, you can go ahead and just hit the graph button. Let's see what it looks like. Probably not going to see the most interesting parts. Maybe we are, maybe we're not. It's hard to say. All right, so what do we know about this graph? It was 4th degree. Let me go back and look at it. We said it was 4th degree. Okay, so that means at most we should have how many turning points? 3 turning points. It looks like it goes up and turns down once. Maybe it comes up twice and down again. So maybe that's 3 times. It's hard to say with the resolution so low. Maybe I want to zoom in on this part because it looks like that's the 3 turning points. So maybe that's the most interesting part of the graph. Let's zoom in and find out. And there's a few ways to do that. I generally like to manually do it, although you can zoom. If you hit the zoom button, you can go down to zoom in, see the down arrow, zoom in, and it wants you to pick see this little blinking, it's blinking slowly, but this little blinking dot right here. Move that, press the up arrow, and that's going to be the center of the zoom. So it's going to kind of zoom in centered, the screen centered around that area. Now, the problem is sometimes this zooms too much, and you might just want to manually set the window, but you can use this as kind of a quick way to zoom in. And we might be all right on this one. Yeah, so nothing's getting cut off the screen. If it was cut off the screen, we'd go into our window settings and we would just manually set the minimum and maximum X and Y coordinates. So it does look like this is going to come down here, and that would be a relative minimum, a relative maximum, and over here it looks like we have a relative maximum. So we see where they are, but on the homework and on the test, I'm going to want you to give me the actual coordinates. Now, how do we do that? To do that, we're going to calculate it with the calculator. So what we're going to do is, if you see up here, there's a button that says trace. Well, right above the trace, it says calc. And so what we're going to do is we're going to hit second trace for calc, and this will let us calculate a lot of things. We can find where a graph is equal to a given value. We can find the zeros, meaning the x-intercepts, and that's going to be useful in a minute, or maybe in another video. And then we can calculate minimums and maximums. So in this case, let's look for a maximum, because I want to find that maximum over there to the left, that absolute maximum. It's going to ask you for a left bound. And what it's going to say, so it wants a left bound and then it wants a right bound, meaning it wants you to pick a point to the left of the point you want and a point to the right of the point you want. And then it's going to search in between there for the point, which is, in this case, the maximum. So I got to press the arrow a bunch of times. And you can see it's kind of slow, so you just got to keep clicking until you see that little blinking cursor go to there's the maximums around here, and you don't have to go that far. Just go far enough that you're convinced you're left of it, and press enter. And it says right bound. Now I'm going to go over to the right. Press enter. And then it's going to say guess, and you can really just hit enter. It's really just in case there's some confusion as to where it is. It will help the calculator figure it out, but I've never seen it really matter. Just press enter. It'll be fine. And so here it is. This is our maximum. The maximum, and you can write this down on your worksheet or on your test. You just write down. I round it maybe to 1 or 2 decimal places. So you could say the coordinates are negative 1.18 and comma 9.19. That would be the coordinates for that point. That is the maximum. Negative 1.18, 9.19. To do a minimum, you'll do the same thing. You go back to second calc, and we'll just go down to number. You can actually just press the number 3 if you want to for minimum instead of scrolling down. All right, now we're going to go back over where we were. Maybe we should have found that one first instead of scrolling all the way over. Now I need to pick a left bound, so I can go and hit enter now because I am to the left of it. Just make sure there's not another minimum in the same region that you select. And I'm to the right of it now, probably. Let's go a little further. Right there's definitely to the right of it. We'll press enter. Guess, press enter. There's the minimum. Now this number right here looks kind of weird. It's got an E in it. This number is actually 0. The minimum here is actually at the 0.07. This is 1.5 times 10 to the negative 6, meaning it's decimal point, 6 zeros, and then 1539. And that's actually just a glitch with the calculator. The number is actually supposed to be 0. The calculator does some type of approximation to find these points, and so it's got a really small number, very close to 0, and that's just a little bit of an error in its rounding or its approximation, whatever it's doing behind the scenes. When you see a number like this, that number is actually just 0. Very small. E to the negative 6 is very small. So the minimum, you would just write down 0.7. And just one more to make sure we get all of them. We'll find this maximum here, which is again a relative maximum, whereas this was an absolute maximum. Second, calc, maximum, so I press 4. And I could actually just press enter now for my left bound. And then I go to the right, and just make sure you're definitely to the right of it, but don't go too far. That's good enough. Press enter, then guess, press enter. And the maximum is 0.437.14. And that's how you find minimums and maximums.